That was not me. Welcome everyone to our May ChicagoRuby meetup. For reference, we aim to meet every first Wednesday of the month. And I want to thank Avant for letting us use this space and for being such a gracious host. And in that manner, I am actually going to turn it to Scott from Avant.
Oh, thank you. Hi, everyone. My name is Scott. I'm an engineering manager here at Avant. We're happy to have you all. Really briefly, Avant is a fintech company. We offer credit cards, personal loans to our customers, direct to consumer. Our engineering team handles everything related to that. So onboarding, financial transactions, a lot of data flow, that kind of stuff. We have a Ruby on Rails monolith that we're actively moving into services. Stop me if you've heard that before. Services based in Ruby, Python, that type of thing. So yeah, we're welcome. Happy to have you all here. I think everyone's seen the pizza by now, but enjoy the pizza, enjoy the soft drinks. The restrooms, far wall, all the way back down on the right. And yeah, welcome, enjoy your stay. And back to you, Michelle.
Thank you. All right, just a couple things before we get started. First, join us for our future events. We'll post our events through meetup.com, meetup.com/ChicagoRuby, and we'll also advertise our events on these channels on the Ruby Central Community Slack, Meetup USA Midwest, and Community Social Random. And we'll also post within the Chicago Tech Slack. Reach out to me if you need any invite to any of these Slack channels. Next. Yeah, we are on the lookout for organizations willing to host our monthly meetings, such as this one. If interested, reach out to Anton, Daniel, or myself. Anton is somewhere. Daniel is there. Anton is there. Daniel's there. I am here. Okay. All right. Interested in speaking? We would love to hear from you. Feel free to reach out to me, Anton, or Daniel for more information. If you're interested in speaking but unsure what to talk about, or if you're interested in hearing a specific topic, we've compiled a list of potential topic ideas that members of the community are interested in learning about. That is in this QR code, as well as the short URL of like a Google Doc of our talk topic ideas. Feel free to add your ideas here. For moderation purposes, this Google spreadsheet is only open for comments. Admins like myself will add your ideas from the comments onto the list. All right. Yeah. If you're interested in supporting ChicagoRuby, either by hosting a different type of event like a hack night or lightning talks or code and coffee, or through sponsorship, we are so down. Let us support you, support us. So reach out to me for more info. And last, join us next month for our June meetup. It will be at Chime. It will be probably amazing because we will be having some extra guests from out of town coming and joining us remotely as well. So I will share more details about that as we get closer to the event. But yeah, something to look forward to. Yeah, with that, I'm going to stop sharing my slides and I'm going to turn it to Joel, if he's here.
Hi.
Yeah. All right. I'm going to turn off my mic right now. But yeah, on to you.
Will you be willing to put the mic somewhere where people can heckle me properly with it?
I turned it off. But yeah, I'm going to give it to Daniel because he can heckle.
Great. Let's see here. I'm going to get a few things set up, but I should be pretty close to ready. Let's see. All right. This meeting is being recorded. Apparently I have to consent to that before I share my screen properly. All right. Can everyone hear me well? Can I get a thumbs up? Awesome. Gosh, thank you, Avant. Your space is amazing. I've been giving meetups remotely this year because my wife and I are expecting a new baby boy in 2 months, which means that I can't travel for conferences. And it's been really cool to see all the remote spaces that companies have. It really is the next best thing to presenting in person. I wish I was there with all of you to eat pizza and chat more. But yeah, thank you all for having me. I'm happy to take my questions during my presentation as well as at the end. I find it goes just as well to do them mid stream of consciousness versus at the end of the talk. But besides that, I just want to start with some gratitude, first and foremost, for all of you for having me. I really appreciate it. I'm also really grateful for the Ruby community, and I'm proud to be part of it. So as a quick intro, my name is Joel. I live outside of Boulder, Colorado. I've been building for the web for about 20 years now and have spent about the last decade in Ruby on Rails. Outside of work, I love spending time out in nature. This picture is taken about a 10-minute drive from my house. Minor sales pitch for a living in Boulder. And I love hanging out with my wife and our 22-month-old son. I currently work at GitHub as a staff engineer on the Ruby architecture team. We're a group of folks that make changes to Ruby and Rails that support the long-term health of the projects and GitHub's use of the projects. Over my time here, I've worked on creating and maintaining the ViewComponent framework, which some of you might have heard of. I've also worked on building out our design system and most recently spent about 2 years being the lead engineer for our accessibility program for the company. So I've been at GitHub for about 7 years now, and I still have no plans of leaving, which feels really weird to say, given how short my job tenures were before I came to GitHub. I really love our culture, the problems I get to work on. I have wonderful colleagues, and it's crazy to say that those things are just as true now as they were when I joined. And I realize how privileged I am to say that. So today I'm going to reflect on what I've learned working on our UI architecture and what I think lies ahead for our discipline in the future. My goal here is to share our experiences so they can help inform similar decisions you might make in your careers. So being here at GitHub for so long has really changed my perspective on being a software engineer. One of the greatest parts of working on really just our one monolithic code base for so long is getting to watch the entire life cycle of my decisions, things that I had as an idea, watching them go to prototype, internal release, public availability, being adopted by our customers, and finally, maintaining them and keep the lights on support, or even sunsetting them. There really is so much to learn from all of those stages of software engineering, but I think that exponentially so, there's even more to learn from seeing a single idea you have go through that entire life cycle. And when you're switching companies every year or 2 or 3, we often as engineers miss out on learning those lessons because we only see a slice of the life cycle of our ideas. So I'll start with my usual disclaimer. GitHub is a big company. What I'm sharing might or might not be directly relevant to your specific situation. To this day, all of our customer-facing traffic is served from our Rails monolith. It's backed by a few dozen supporting services, but all the traffic goes in through Rails. And I always like to share some stats about the scale of our monolith. And this time, I wanted to do something better than just numbers. I wanted to provide time series data. So I went out and wrote a script. Think of it as Rails stats. How many people here, raise your hand if you've used Rails stats before? Okay, 1. All right, so Rails stats is a command that tells you the number of controllers, models, views, etc. that you have in your code base. And I made something similar. And what I did in the script is it checks out the github.com monolith from day 1, and then a month later, and a month later, and a month later, all the way up until December, and runs the same analysis. And I plotted this on this graph. So today we have about 5,000 models. We have around 4,000 routes that render UI and about 2,100 controllers. And depending on the month, we have about 650 people actively contributing to our monolith, meaning they wrote a commit in that month. I've open sourced the script for this. The link is at the bottom of the slide. I would love to hear from all of you if you want to run it in your code bases. I promise it won't mine Bitcoin. It won't send me your passwords or anything. But yeah, with that out of the way, let's get to it. I kind of have 3 lessons I want to talk about today. One is that native is the new baseline. 2, that there's a paradox when it comes to UI abstractions, design systems, and that I believe, after all these years, that front end in the long term costs 10 times back end. So native is the new baseline. GitHub's UI has gone through several eras, and you can see them to this day if you are able to look at our code base. One way to visualize this is with a tool called Git of Theseus. Running it on my souped up M1 Max took we have 2 million commits on our monolith at this point. It took, I think, 96 hours to run, but it gave me this cohort retention graph. So what this is each color is a vintage of code, meaning a year in which the code was authored. So for example, if you were to look at the list for 2023, you can see, or the data for 2023, you can see that's that teal here towards the top right. And that teal, you can see how much we added versus how much was already removed or changed in 2024 or since then. But as you can see from this graph, in general, the code that we write sticks around and is untouched. We aren't necessarily going back and deleting or significantly changing what has already been written, which means that a lot of cases, when we write a commit, it's frozen in time. That is, until we have no choice but to change it. And in my time here, we've significantly raised our standards for building UI. And that has the effect of making doing things the right way increasingly complex, and has thus required us to go back and change code. And one of the reasons is that we've made really significant efforts to improve the accessibility of our products, working towards WCAG compliance. But we've also worked hard to improve our availability. For a long time, we accepted some amount of UI regressions as normal. While we never really measured how many times we shipped UI bugs to production, it was generally accepted that we would never catch them all, but that we could rely on our ability to fast follow, with a rollback or a bug fix whenever we, notice regression, or often in this case, like this is a bug from Twitter from the other day. Like this is something that someone tweeted at GitHub and said, hey, we think something's broken. But that is no longer the case. We now consider UI bugs like any other bug, counting them against our availability scores if they are blocking users from using our product. So our standards for availability is at a minimum 3 nines or 99.9%. Does anyone here know how many hours a year of downtime 3 nines of availability is? Anyone want to guess? Come on, I got to hear something. Give me a guess. What's 3 nines of availability? 99.9. 2 minutes? It is 8.5. It's 8.5 hours. So in the entire year, if you're aiming for 3 nines, you get 8.5 hours of downtime. So in our case, to write a commit, put it through CI, and deploy it, it's at least half an hour. So that means that we get 17 commit and deploy level fixes per year to maintain 99.9. And remember that we have 650 people committing every month. So that leaves very little room for error. So in discussions with other peers in the industry, these availability and accessibility standards are generally far above the norm. They're really an exception to the rule. Many companies don't prioritize this stuff as much. And this can mean that when people come to our company, they don't understand the implications of those standards and may expect us to deliver things with less attention to detail, or I think you might call it like shipping to learn, or shipping like a minimum viable product. And this is especially true for people coming to GitHub from organizations with more lax expectations. But beyond availability and accessibility, there's also this kind of more vague pressure to make our experience more app-like. And the first case of this that I saw was when we rebuilt GitHub projects. Customers were asking for features well beyond our existing feature set. And more broadly, we are seeing companies in our space innovate with more app-like experiences, both in browser and inside editors, as I'm guessing many of you have seen with some of the in-browser AI assistants, for example. And this has led us to adopting React. And while we don't have plans to rewrite GitHub in React, we are building a lot of our new experiences with it, especially when they are in this more app-like category. And when we made this decision a couple of years ago, and since then we've added about 250 React routes. But that subset of our larger number of pages actually makes up about half of the average pages you probably use in a given week as a user of GitHub. This graph, by the way, is also generated by that history tool, but you need to modify it for your code base if you wanted to do the same measurement. But I think the root cause of this pressure to be more app-like is really much broader than just our competitors. As software continues to eat the world, a new population of consumers is emerging. So according to Pew Research, about 15% of US adults only access the internet through a mobile device. And to me, what's more worrisome is that, depending on who you ask, although the stats are pretty consistent across measurements, about 90% of internet usage on mobile devices is in native applications, not in the browser. So that means that if you're using native applications all day, when you go to the web, that experience is likely going to be a step back, just given how rich those native experiences can be. And that's just the US. The situation is way more stark depending on the country. So for example, in India, only about 22% of urban households even have a computer. And if you go outside of urban spaces in India, that number goes down to 5%. Which is all to say that I believe native is the new baseline for our UI work. And we're trying to match it using a technology stack that was originally built for displaying documents. And while the web has come a long way, it wasn't built from the ground up for building experiences that compete with the fidelity of native mobile applications. And I know I'm not the only person in the Rails community who has desired to keep the web the way it was, but I believe times are changing. So I have a question for you all that might help illustrate this point. Raise your hand if you would book an entire vacation using only your cell phone. One person. So what I have heard is that if you answer yes to that question, it means you are younger than a millennial with very high certainty. And if you answer no, it means you are a millennial or older with very high certainty. And I ask that question not to single anyone out, but to make the point that I think that this could be a real blind spot for us, that as us engineers have a certain perspective on the world, we can really be unaware of the larger trends going on in our markets that we're serving. So I'll really admit that this realization snuck up on me. I think that that's like maybe kind of the real lesson here, is that like there are very real trends that can happen in the industry that we can be completely unaware of. So I would say that while everything's different depending on the company, my kind of lesson with this is that given that native is the new baseline, we really should be considering how our app compares to our competition, especially if our competition has a native mobile experience, because increasingly that's going to be the way that our customers are going to be comparing our products. Any questions before I continue?
Joel, I actually had a question
Sure.
about some of the migration to React. Does that mean that you guys are taking your Rails monolith and also treating it as a JSON API too? Or are you serving up React server rendered components, or what does that maybe logistically look like?
So yeah, I can speak a little bit to the architecture. I was really trying to avoid having my talk being this year being about how GitHub does React, but I'm happy to answer those questions. So our approach for React is we do JSON APIs. We will do server rendered what we call JSON islands to pre-populate the page. We will also do server-side rendering through an isolated process that we run. It is not React server components. It is not Next.js. It is something we built with heavy consultation from our friends at Airbnb.
Cool, thanks. I won't force you to talk React any more than you have to.
I can talk it as much as you want. I'm here all night.
All right.
Any other questions?
Your audience is mostly developers, though. Why do you care about rural India that's using only cell phones, right? I don't understand.
You'd be surprised how people use GitHub. Especially, just think about it in very broad terms. I can't talk about business specifics for obvious reasons, but we have a lot of people who use GitHub. As we continue to grow, the people who are new to GitHub are disproportionately in more rural areas. They're disproportionately using lower powered hardware and honestly, even doing way more than you would think in the software development lifecycle on their phone. So for example, I wasn't trying to say
that's
that
what I don't understand. Yeah, that's what I don't understand. How do you do programming on a phone?
Okay, so for example, this blows my mind, and this is to illustrate my point earlier about a blind spot. There are college professors now who are saying that the majority of their students write their essays completely on their phone. I cannot think in that way on my cell phone, but people are doing it. People are writing code in GitHub Mobile. It's happening. I cannot tell you stats for obvious reasons, but our mobile app is way more popular than I expected. Way more popular. People are doing a significant portion of the life cycle.
You guys have a mobile app?
And again, I can't say numbers, but like it's shocking, like what percentage of our active users use the mobile app. It's very high. Right. Yeah, and they use it for increasingly more and more of the life cycle. Yes, there are some tasks still that are likely. That's a laptop task is a thing I've been told insultingly because I'm a millennial. Oh, you got to do that on a laptop because you didn't grow up on a phone. But that's the divide I'm talking about. That kind of disbelief that a phone could do everything in someone's life cycle for a given product.
I see. I mean, I'm done. I mean, you can go on. We'll see how it goes, right? But it's just strange. I do have, my son is 14, right? Just saying. And he does Scratch programming, and sometimes he does it on his phone. Those drag and drop blocks, which is, I would find it super annoying, but he manages to do it, right? So I see your point, but I still,
and also, and maybe the reality is more in the middle between your perspective and mine. So for example, you use a tablet, you might be using web, you might be using native, but increasingly we're seeing people ask us to make github.com more like GitHub for iPad, which is telling to me. That's like a common feedback we get. Oh, I love GitHub for iPad. I'm so productive. It's so fast. The UI architecture is more clear to me. Make the website more like that. Any other questions, comments, heckles? I'm here for it all. All right, I'll keep going.
I think we're good. Yep.
All right. So of all the ideas that I've really seen go through their entire life cycle in my time at GitHub, it's design systems. So as our availability and accessibility pressures have mounted, more and more teams have looked to our design system to help them meet those standards, as they should, right? That's, at least in my mind, the value proposition of a design system is to make accessibility, consistency, even availability more cost effective for a large organization. But it's had the effect, rather unfortunately, of putting a lot of pressure and really the hopes and dreams of many of our UI goals of the company on the shoulders of the very few people who maintain the design system. In our case, it's less than a dozen engineers versus the around 650 working on the monolith. And you can see this pressure manifests itself in the very architecture of our design system. So for a long time, Primer was just a library of CSS classes, much like Bootstrap was and Tailwind is today in some respects. And in fact, Primer was in part originally created by Mark Otto, who also created Bootstrap. So the similarity is intentional. But as we looked to improve availability and accessibility of our UI, we found that it was necessary to encapsulate our markup and behavior, not just styles, like everyone else in the industry has found, leading us to React and Vue components. But honestly, for us, having worked on it for years now, it's really been a struggle to build and maintain a design system that meets those high standards, especially what's effectively 2.5 implementations of it. We reuse some of the code in between the CSS and ViewComponent implementations. And in many respects, our design system has become a victim of its own success, because the more it is adopted, the harder it is to change. And our experience has been the perfect example of Hiram's Law. I think there's an XKCD about this, but basically Hiram's Law, it says that with a sufficient number of users of an API, it does not matter what you promise in the contract, what you document, what you have in your code comments, even what the method signatures are. All the observable behaviors of your system will be depended on by somebody. And the XKCD is something along the lines of like an Emacs configuration that ends up heating someone's spacebar, and they complain when this bug is fixed, but they like that their spacebar was warm. So an example of this is our button component, right? This is very simple, but it's used 5,000 times in the GitHub monolith, 4,000 times in Rails-based UI, and about 1,000 times in React. And sometimes it's used in ways we don't anticipate or have test coverage for. And while we do what we can to isolate the styles, the global nature of CSS makes it difficult to have the level of confidence that we need to sleep well at night when shipping, honestly, increasingly small UI changes. So what this means is that making changes to this button are really hard to make confidently, no matter how small they are. I would say that upgrading the primer dependency in the GitHub monolith has become increasingly stressful and one of the more difficult jobs at the company. And while we've made strides towards reducing risk with tools you might think of like feature flags, visual regression testing, etc., we still ultimately have to rely on manual testing. And if you compare this to similarly shaped problems on the back end, we're significantly behind in terms of confidence in our releases. But I think there's a bigger problem here. Why are there so many design systems in the first place? We're all inventing solutions to the same problems, and I can't help but feel that there's a great deal of human potential being wasted on a duplication of effort. So you want to see what I mean? Like, let's just take a look. So our peers at Zendesk, also a big Ruby on Rails shop, here is the same button component documentation from their design system. Let's see if I can load it. I'll switch back and forth. Literally, even the website, like the information architecture, even some of the subheads on the right side table of contents are the same. It's uncanny. And some of you might see where I'm going here. I believe it's time for us to consider a global design system. And I'm not alone. Brad Frost is a big voice in this space, and he's leading an effort. I encourage you to read more if you're curious. But what does this mean for you? I was recently asked by someone about whether their company should build their own design system from scratch. They had a single designer and a handful of engineers for the whole company. And here's what I told them. GitHub can barely afford to do a great job maintaining 2 implementations of our design system to our own standards. And even at our scale, we don't build all of our UI ourselves. So for example, when you use GitHub projects, you're using React table. When you're looking at charts and graphs on github.com, that's high charts. And we've even toyed with the idea of theming an existing design system, something like Radix or Shoelace, instead of building every new component that we need ourselves. So the UI abstraction paradox is real. I would just say beware the cost of reinventing the wheel and try to reuse existing design systems when you can. So that's section 2. Does anyone have any questions, comments? All right, I'll keep going. Maybe this should have been spicier.
Question.
Oh, got a question? Okay.
I do. I mean, I think there's something interesting here. You notice a fragility, right?
Right.
the fact that you have dependencies on your button all over the app. What you want to do, I mean, look, I don't mean to criticize, okay? But you want to make that fragility global, right? Like, it's going to make, like, for example, you have a bank that fails, that's good. But no, you want to have the whole financial system fail, right? So you have resilience if you have localized and duplication. And then you don't have that. And I don't know, you want to save money by making it more global, but it will actually make the system fall globally. You get that? You get that?
Yeah, and I think that's very true of a lot of abstractions, that the more you standardize and you create these layers that are shared across systems, they become naturally more fragile because of Hiram's law. Yeah.
Yeah.
I agree with you.
It's worrying though. It's worrying I see that it can save money, but on the other hand, efficiency comes at the cost of resiliency and anti-fragility, right? So you want to save money, but you're going to create a more fragile system globally, right? I mean, good luck. But
yeah, the paradox for us is, right,
about it.
like if you think about, someone who's competing with GitHub or with any large company, they're competing often on a subset of features. So like if a competitor comes in and does a great job at like 50 of those routes, of which we have 2,000, it's gonna be really easy for them to have internal consistency in their UI patterns because they have not reached that scale where that fragility is going to bite them. Versus if we were to say not use a design system, you'd end up browsing around GitHub and things would look drastically different as we build new pieces over time and spend less time maintaining the old ones, right? Like, I don't think any company is going to grow linearly with the number of URLs that they have in their product. Like, as you saw in that previous graph, I'll kind of go back. Like, the number of people committing to the monolith has been much more stable than the growth of the surface area of our product, which means that by definition, we can spend less time maintaining any one line of code over time. So that's where these abstractions become necessary, I believe, to the business. But I think that's also a good example of why maybe they aren't as necessary at a smaller scale. Does that seem fair?
Yeah, I mean, I see your points, and I'm not sure if I understand now all of them, what you said. I keep thinking about the fact that it will save money, right? It will save time. But on the other hand, you think about second order effects. You will have a global system that nobody can change that, right? Because you will break so many other, like, okay, you push this global system, right? It wins, but then it gets stale because you can't change it, right?
I think that it comes down to, and I'll talk about this in the next section a little bit, but I think that like part of what I see as the underlying issue is that the tools in which we build UI for the web are fragile. And I'll explain that more here in a second. That's actually a great segue into the last section here. So I'll go ahead and keep.
I'll listen. Go ahead.
Yeah. So
thank you.
I'm sorry.
Has anyone here read the?
But could I just add that there exists outside of software user interface, there are huge, very fragile systems that can't be changed at all. Like things like, ACH or large interfaces, the air traffic control systems, you just can't change them without tearing the whole thing down. So this is not a unique problem for us.
Right. I think the difference is that, and I'll get to this in the next section, I think we end up doing a much better job with modern backend tooling than we do with modern front-end tooling of being better at that. Any other questions, comments?
We got two of us over here real quick.
That's okay. Sure. No, take your time.
Some scattered thoughts that I'm thinking as I'm watching you, this is great, by the way.
Thank you.
There's another XKCD, really famous one where it's like, there's 14 standards. That's crazy. We should have another one. And then like 10 minutes later, there's 15 standards. And I think one of the big problems that we're seeing is like the universal library is supposed to be the browser, like a button's supposed to be a button. We kind of like re-engineered that from a link with styles.
Do you just want to give the last third of the talk? I can turn it over to you.
Are you going here? Okay.
You could probably roll up the slides pretty well.
I'm just gonna sit down and eat my pizza. I feel great already. Was what you're gonna say too? Okay. Yeah. All right. So yeah, continue, please.
All right, cool. Let's talk about the platform then. So one of my favorite series of articles in the software engineering discipline is called Falsehoods Programmers Believe About, and then a certain thing. Has anyone heard of these articles? No one. Oh, these are such a good read. I recommend it. The first one I read about was Falsehoods Programmers Believe About Time. I remember reading this list and being like, yep, I've written a bug around every single one of those. Another one is names. This one, for example, people's names are written in ASCII. That's one that has bitten us here at GitHub. Another one is that people's names are case sensitive or insensitive. And in fact, in my research for this talk, I found a meta list of these as usual on GitHub. There's an awesome list called Awesome Falsehood. But I think there's actually an article missing from that list. If you go to Awesome Falsehoods and you search for UI or interfaces or design systems, there is not an article called Falsehoods Programmers Believe About UI. But I think this article by Dave Rupert comes pretty close, and it's called UI's F of States, raised to the N. And in his article, Rupert really elaborates on the dozens of runtime inputs that can affect UI, many of which are outside the control of us developers. So for example, browser extensions. When I was working on incoming UI bug triage for GitHub, about a quarter of our UI bugs were caused by browser extensions. If you opened the page in the same browser, in incognito or without any extensions, the bug would go away. And this is madness coming from the backend world, right? Like we're Rubyists. When we run GitHub, we run all of github.com on a single version of Ruby, except in the rare cases where we're testing the performance of like Ruby master. We sometimes do that in prod. But when we write, our HTML, CSS, and JavaScript, it runs on several major versions of every browser, right? Across a matrix of hardware stacks. I know I didn't include them all. Sorry, I didn't get everything on the slide. People have heckled me for that before. And yeah, across major versions, right? Like there's actually there's like a three-dimensional, decline this. Let's see. There's like a three-dimensional aspect to this. Weird. So Zoom is saying that someone is requesting remote control of my computer. Okay, I'm just going to trust. Oh my gosh. Okay. So given all this runtime complexity, you would think with so much more runtime variety that we would test our front end code so thoroughly, right? Like at least as thoroughly as our back end code, right? Raise your hand if you feel like in the code base you worked in today, that you think your front end code is tested as thoroughly as your back end code or more thoroughly. No one. And that's not a huge surprise to me. I think that's actually pretty common in the industry. I would guess that we test our front end code on average as an industry at least half as much as we test our back end code. So why aren't we testing it to a similar or if not greater degree given this runtime complexity? So for one, I think we can generally agree that browser tests are tricky. They're slow and flaky compared to our backend unit tests, but it's also, I think, more structural. Our backend code is more able to be tested than our front end code. Before we had the idea of components, we really didn't necessarily have a great abstraction to test that wasn't just visiting an entire page and clicking on things. So that's how we've written a lot of our UI tests historically at the system level, Rails system tests. But thankfully, as we move towards component-driven UI, we are quickly turning the corner on this issue. And at least at GitHub, we have effectively total test coverage for our components because when you generate a new component, whether it's React or a Vue component, we generate tests for you and then lint to make sure that you added test cases. But that isn't enough. At least I don't think so, because of just how varied our front-end runtime can be. So think about the amount of tooling and research around making perfect backend code. For example, with a bit of math, we can prove that mission-critical systems, originally these tools were invented for avionics, but they use them now for systems like S3. We can guarantee that those systems are immune from certain failure modes. Literally, this is how S3 gets 10 nines of durability, because they use what these are called formal methods or formal verification to verify their systems are correct. And in doing research for this talk, I was able to find one formal verification paper on UI period. And I kid you not, it was written by someone who wanted to formally verify that their cookie banner was shown on the page and that it wasn't like overflowed off the screen, which tells you something about the state of research in our field. So as our application goes, so does the amount of front-end complexity that we have to manage. So if we look back at our graphs, the top one is the one we saw earlier around usage of React. I attempted in the bottom graph to measure the number of lines of front-end code per contributor. So for front-end lines of code, we sum the total number of lines of SCSS, CSS, ViewComponents, ERB, JavaScript, TypeScript. I excluded all of our test code. And that number was very stable per contributor in our monolith for literally a decade. And that all changed when we started adopting React. And this sign is concerning to me. Wouldn't we expect our UI code to become less complex over time, given the fact that we're learning more and more about our discipline and creating better abstractions and hopefully having a more usable design system, for example? Well, one contributing factor that I've observed here is that design as a discipline is not bound by the same constraints as engineering. There really is an imbalance in change costs between engineering and design. A designer could build a year's worth of engineering time in a week, maybe even a day or an hour. We have designs here at GitHub that, albeit were very aspirational, but they were done 4 years ago that we are still aspiring to implement across the company. And because there's very few natural limits, it's really easy to build designs that are difficult for us engineers to implement. But the reality for us is really more subtle. It's pretty uncommon for us to intend to deviate from a design system. We have an excellent Figma setup, but because we are designing in an environment that is removed from the target medium, there is no guarantee that what is designed can be built with our component libraries, at least without compromises. And I really see an opportunity here for us to build our prototypes, say in React instead of with Figma, as doing so would eliminate this gap. But more broadly, I believe that as our application grows, we are most successful when we allocate our complexity for where it's most necessary. Let me give you an example. So for us, that might be things like diffs. This is a unique UI pattern that you don't see many places on the internet. This is not in many design systems. You might also have things like 4-dimensional drag and drop, where you click and drag a card in GitHub projects onto another card to perform an action. Or I would say the crown jewel, perhaps, of GitHub's front end, what we call the merge box. We recently rewrote this in React, and it was a massive undertaking. But these, what I call unique kinds of UIs, have less convention and often unique accessibility characteristics and challenges that are very expensive to solve. But a lot of the time, I think our budget for building UI should be zero. We should build with something that we already have to copy and paste, or to use something that someone has built already. And I think this doesn't matter just for technical reasons. I think that our customers, the people who are using the software we build, are really going to prefer this. Because if you put yourself in the shoes of someone today, they're living their life, every single thing the company they do business with has an app, they have a website. Do we really expect people to relearn how to do the same common task every time they work and do business with a new company? Like, imagine if cars worked this way, that like you go to rent a car and it was from a brand you never heard before, and the accelerator is on the steering wheel instead of on the floor. Like, that would be nuts. We would never do that. And let me give you a practical example of this, like e-commerce checkouts, right? Like, it's 2025. Why is there more than one way for me to enter a US shipping address on the internet? This is actually one of the reasons why I really like that Shopify has been so successful, because when I see a Shopify checkout page, I just know how to fill it out. I know all the little quirks and I can get through it. And to be honest with you, I've really had to fight with my inner artist to view everything as art in this discipline. But really what we're building is tools for people to accomplish things. And don't get me wrong, I think that art is a great way to be creative. But this isn't the place to prioritize it over the usability of our products for our customers. So what's exhausting for me about this problem is that things could not be more different on the back end. We regularly use and improve libraries that already exist almost as a rule. I would argue that the only reason we're even all in the same room together today is because we reuse the same libraries and we can talk about them and contribute to them together, Rails being one of the main ones. So as Rubyists, I think we are really good about working together to improve open source software. We contribute changes back to Rails based on our experiences using it. And I think the same should be true about UI frameworks and even browsers themselves. So one of the most inspiring things for me as I've done this work is to see my now former colleague, Keith, work to improve the greater ecosystem. So for example, Keith has worked to improve browsers to the point of enabling us to remove custom polyfills and other behavior from the github.com codebase. In about 18 months, he contributed 100 patches across 5 different browsers. This is very impressive. This is very unusual. It, of course, caught the attention of a lot of people, and he now works at Mozilla on Firefox. So what can you do? Well, I'd recommend thinking about UI complexity as something to budget for, and then spend it wisely, only inventing as little as possible. Because if there's anything I've learned while working on GitHub's UI architecture, is that the equivalent amount of code complexity costs 10 times as much in the long run when it's front-end code versus when it's back-end code. So in conclusion, I believe native is the new baseline. We should consider how our app compares to our competition, especially if they have a native app experience. The UI abstraction paradox is real. Beware the cost of reinventing the wheel and reuse existing design systems whenever possible. And front-end costs 10 times back-end, so budget accordingly. Thank you. And I want to thank my peers, Francis, John, and Josh, who are my peer reviewers for this presentation. And and we are hiring. We have some open roles in the UI discipline and across the company. We are looking to hire a principal engineer in UI architecture, someone who's like a React GraphQL expert. So if you know anyone, we are looking. Any other questions? Comments? Heckles?
For that native is a new baseline thing, what's the stat that you're looking at, like volume or hits? So imagine, for example, like Netflix or YouTube in the native app, serves a ton of traffic for users globally, and also just data. I'd be curious to know, versus other things. So what data are you using?
So I can just go back because I have the citation there. We can grab it. So this is time. Time in app, or basically time in any given like app versus non-app. So you're right. If someone's watching Netflix, they aren't like tapping around all the time. That's a fair point.
A simple counter is like no. Again, and no insult to any other country in the world or new generation that's coming up, but no real work is done on a phone, right? Like office buildings and spaces, laptops are a requirement, desktops, that sort of thing. I understand what you're saying, native first, and got to keep that in mind, and we can lose touch with that when we're on our desktops all day. But just it's a interesting dichotomy between like the consumer versus the producer, I guess.
I would just say that was kind of like a discussion I was having with the commenter earlier. I'm not so sure. I'm not necessarily confident in that, like consuming versus producing. I'm certain that there's more producing being done on, like, I would guess that the balance is more towards desktop, but I would not rule it out. Like I was saying, we are seeing people produce things on phones that you would never expect. We would never expect people to do that with just a phone.
I was curious if you're able to tell when people are using their phone, if they're actually using the keyboard or if they're just dictating. Because if they're speaking into the phone, I could absolutely see how it would be productive.
That's a good example. That's one of the things I was kind of going to add earlier is that, like, I think that as AI becomes more of a thing, you might need less fine input. And that's where mobile devices can become more viable. I will say that as a rule, we do not measure use of assistive technology. It's hard to do accurately, and most people would argue that it is counterproductive.
Hey, yeah, I have one more question. And my question is that, would you say that such maybe even ancient solutions as Twitter Bootstrap is actually a step towards this global design system, because it was there like for 10 years and probably not 10, I think 15 maybe or something. And I think probably hundreds and thousands of applications relied on it.
Yeah, I would argue that Bootstrap is the closest thing we probably have. Tailwind is a little less prescriptive in how you use it, so I think that it's a little less in that direction. But yeah, Bootstrap is the original global design system, and depending on how things go, might be as close as we ever get.
Okay, thank you.
Any more questions? Oh, leave it for one more minute before we turn it to our next speaker. All right. Yeah. Thank you, Joel. Yep.
You're welcome. Thanks for having me.
Yeah. Thanks for coming. All right. Well, we have one more speaker lined up, folks. Chelsea Troy is coming. I will help you get set up too. Yeah. I sent you the most. Oh, perfect. Yeah. All right. I will hand over the mic to you.
Amazing. Yeah. Thank you. All right, let me go ahead and get my slides shared here for a moment. I teach on Zoom for the University of Chicago, so you would think that I would be good at Zoom by now. I'll just leave that there. I'll join with computer audio. Should I join with computer? All right, are folks in the Zoom able to hear me?
Yes, it's excellent.
Yeah. Okay, fantastic. How do we do this? I have done that. The laptop is muted. We're all good? Wicked. All right. So let me go ahead and share my slides with you. And I'll do that by hitting this button, and then I'll hit that button. And so you should see a nice blue background, and it should say, how does GenAI affect developer productivity? Perfect. We're good? Amazing. Well, first of all, I'd like to thank ChicagoRuby for having me. I don't do a lot of Ruby these days. I work as a machine learning operations engineer. I lead the MLOps team at Mozilla. We make a browser called Firefox that still exists. Yes. I think we probably have a couple of Firefox users in the room. We tend to in programmer audiences for sure. Excellent. So I lead the machine learning operations team at Mozilla. My day is a lot of Python, a lot of SQL, and a lot of Terraform. I don't spend a lot of time in Ruby editors, but I spend some time in Ruby editors for teaching. And Ruby is where I started my career. The first time I ever went to a meetup, it was a ChicagoRuby meetup. It was held at ThoughtWorks. It was over a decade ago. And the first time I ever spoke at a meetup, it was also a ChicagoRuby meetup. So I have a lot of gratitude for the Ruby community. It has been my first meetup, my first speaking opportunity, my first hackathon, and second hackathon and third hackathon were all in Ruby. And so I have a lot of love for the Ruby community. But today I'm not going to be talking specifically about Ruby. I'm actually also not going to be talking about what I work on in my day job at Mozilla. I do machine learning operations, but what I do besides that is that I teach. I teach at the University of Chicago, master's computer science students, and there I also work with them on some research into the impact of generative AI on developer productivity. And this is a question that I get a lot in my day job. I get it a lot from my students. I also get it a lot from folks who are taking other workshops that I'm giving. I give professional workshops through O'Reilly. How generative AI is expected to affect developer productivity is probably the number one question that I get in all venues, basically regardless of what type of technical audience I'm talking to, or what the subject of the presentation I'm giving is supposed to be about. So I decided to go ahead and make a presentation that was about this specific thing. And what I'm going to talk to you is about what we know in response to the question, how useful are these tools for the work that we do generally as developers. I'm not going to do a lot of speculating. I could sort of try to generalize based on my experiences working with colleagues and interviewing candidates and teaching students who all make heavy use of these tools, but I'm actually not going to do that either, at least not until the end. What I do want to do is talk to you about some of the nascent research results that we are seeing about the impact of large language model use specifically on work productivity. So I'm going to leave out like stability AI image generation stuff. We're talking specifically about large language models here. So I'll be candid with you. When I started doing the research for this talk, I was hoping to find some kind of survey study comparing the utility of these tools based on what kind of engineering work you were doing with it. I wasn't able to find anything systematic on that. I was only able to find anecdotal evidence favoring, as you would expect, programming languages with ample usage examples in the Common Crawl. The Common Crawl is a data set of data that has been crawled from the internet on a monthly basis since about 2008. As you can imagine, it is an enormous trove of web text data. The comparative studies that I could find did evidence some patterns in large language model outputs that feel particularly relevant to software engineers. So I'm going to start there. With this paper from Wenping Hu and Zhicheng Ji, which mostly took the same prompts and ran them through a bunch of different actual language models to decide which replies they liked the best. This particular paper favored GPT-4 for work on programming problems. I can acknowledge the value of a theoretically unbiased evaluator comparing the large language model products of various companies, but I don't find this to be a satisfactory answer to my question all by itself of how to use these tools effectively and where these tools can be useful. So we'll move on from here to this paper. If you're familiar with some of the research on large language models, you might be familiar with the idea of this paper, Lost in the Middle by Liu et al. This paper is one of, I would call it like the 5 cult classics of large language models. There's this one, the Stochastic Parrot paper, and a few others, which I can get to a little bit at the end if folks are interested. But this paper discusses the likelihood that a model can successfully retrieve information from a bolus of context included with a query based on how large that bolus of context is. Do I have anybody here who's ever just pasted an enormous amount of text into a large language model UI to see if you'd be able to get out the accurate result? A couple of people, fantastic. So this is the paper that established in academic literature that big context, more information, make it less likely that a model will successfully retrieve an individual fact. It also established that models are more likely to retrieve the information if it appears at the beginning or at the end of the context, as opposed to in the middle, which is how we get this title, Lost in the Middle, which actually I would say is on the less punny end of academic paper titles about this topic. But what does this mean for us? It means that even when we're including a context document in our input query, it's in our best interest to narrow down that document to the relevant section as much as possible, not just ram in a manual the size of War and Peace and hope for the best. So then, even more recently, we get this paper. By the way, I understand that these abstracts are too small for you to read. This is mostly here to prove to you that the paper does in fact exist and was not hallucinated. I went and I found it, and it exists, and it is real. The papers that I'm telling you about, yes. So this one is by Dumitran et al. And evaluated large language models against competitive programming prompts from the Romanian Informatics Olympiad. They found that model solutions had more success in C++ than Python, interestingly, and that Gemini, which is the large language model from Google, produces more code that's more similar to that of competitive programming than ChatGPT does, which produces more. The paper worded it as production ready type code. I would probably characterize this more as like heavily commented code. We technically do not know the precise sources of training data for either of these models. Closed source development is the standard in large language model production right now. But given that Gemini is made by Google, a company with an enormous volume of proprietary software, one wonders whether Gemini's proclivities for competition-looking code belie what one might find in, let's say, an average Google repository. Now, this paper is particularly interesting and is the one I'd like to spend the most time talking to you about. This paper by Cui et al. Gained some notoriety in the programming zeitgeist as the 26% paper, with the idea being that it says programmers are 26% more productive with large language models than without. So I want to dig into this claim a little bit. First of all, the proxy metric in this paper is number of tasks completed. And the 26 statistic is coming from the fact that the conclusions claim to have seen a 26% increase in this number. Of substantive import, in my opinion, to the context from which the statistic derives is that the conclusions outright say that less experienced developers showed higher adoption rates and greater productivity gains than those with more experience. I think this introduces a number of confounds. So first of all, less experienced developers tend to receive smaller work tasks. So increasing the number of work tasks they do by some large percentage would be a lot easier than if the tasks were something like spearhead this giant legacy migration. It's also the case that more junior engineers tend to receive the tasks that require the least context, the exact thing that we've already identified as the Achilles heel of many of these systems. A large language model can be a great help in writing a function from scratch, given a series of tests that it must pass. Have folks tried this? Maybe given it a try? Yeah. So at present, these models often cannot, say, identify the insidious scope issue causing data corruption in a 160,000 line code base. And that's the sort of risk, or rather, it's the sort of task that's more likely to be assigned to someone with more experience, because there may be more risk associated with getting something like that wrong and more skill associated with accomplishing that task effectively. To me, this pattern demonstrates the deepening of an existing cognitive dissonance in programming education. We teach students, train new entrants, and interview candidates chiefly on their ability to write code from scratch. But as they advance in the workforce, their actual main responsibility is often reading, analyzing, debugging, or reorganizing code that they themselves did not write. I see some nodding around the room. Folks feel like this is the thing that we do professionally? Yeah. Once upon a time, writing code from scratch comprised 90% of computer science educational assignments, and it's generously, I would say that number is coming down, but I would also say that it's generously 20% of programmers' professional responsibilities in the editor. I certainly spend less than 1 day a week writing brand new code from scratch. That mismatch, thanks to the advent of generative AI tools, has become even more stark. The reason for that is that those tasks that once required writing from scratch manually often now include asking a large language model to write it instead. At which point, the programmer is once again reading, analyzing, debugging, or reorganizing code that they themselves did not write. Large language models have not wholesale wiped out programming jobs, so much as they have called us to a more advanced, more contextually aware, and more communally oriented skill set that, frankly, we were already being called to anyway, just 80% of the time instead of 96% of the time. On relatively simple problems, we can get away with outsourcing some of that judgment. As the problems become more complicated, we can't do that as easily. So, what might we take away from all this? I think there are a few lessons worth writing down. The first is this: large language models are most helpful on programming problems that are specific. To the extent that we can provide a complete and unambiguous set of success criteria, we can improve our chances of an accurate answer. This is the reason that pasting in a test suite is more likely than pasting in a description of the function you need to get you the actual function that you're looking for. It's also helpful that those problems be limited in scope. We've narrowed down the context as much as possible to eliminate opportunities for misidentified relevant information. It's also helpful for them to be focused on a programming language with a robust sharing history. As I mentioned before, evidence on this, while largely anecdotal and not, to my knowledge, yet collected in any kind of survey study, is pretty strong. And that makes sense. That if what you are building is a pattern replicator, which is fundamentally what most machine learning models are, they are more likely to be able to accurately replicate patterns that they have seen a lot of, which means that if they've been trained on web data, they're more likely to be able to accurately replicate patterns in code that's in a language that they've seen a lot of. Now, large language models can help us identify implementation options. However, so far, at least, they don't provide an adequate substitute for judgment. The more of our job focuses on experience-based judgment, the less these tools have improved productivity so far. And that is because as we are needing to use that judgment in niche circumstances applied to our specific cost-benefit analysis, general advice on the internet about what you should sort of do becomes less and less relevant to how we solve those problems. For this reason, subject matter expertise and contextual expertise still matter in decision making. This includes expertise in when and whether to use or trust the output of a large language model, even as an initial draft. Finally, by dint of the patterns that train them, the nature of large language models supports reproducing existing logic. They repeat the patterns of language that they have seen, a sort of global average, if you will, of what the internet has to say about a topic. This can be useful when questions have established answers or when programming communities publicly adopt shared norms. But what they can't do in and of themselves is innovate, is break from that pattern of what has been said and taught in the past. The more newness you're looking for, the less you can rely on a large language model's output in and of itself. Conveniently, of course, that describes few of the problems we face professionally, especially today in a very saturated tech market where a lot of what we do is migrate existing processes from tool to tool, and to the extent that we build new services, most of the actual work comprises integrating a set of pre-existing dependencies and vendor APIs together, as opposed to writing a whole bunch of things from scratch. The question I'll throw in that I think the advent of large language model products is still too recent to empirically answer is that I'm going to be curious to see how today's junior programmers, aided as they are by large language models, navigate the challenges that we currently use judgment and experience to manage at the senior level. Folks who are at the senior level now did not learn how to program with the aid of these tools. So the experience of folks who are entering the field now will be pretty different than ours was. With some understanding of what sorts of problems we can expect large language model tools to help us with and not help us with, I think we're led to this question: at what skills does the AI-enabled engineer need to excel? This is where we venture out of the territory of theoretically, empirically supported claims and into the territory of my perspective. As I mentioned, I would leave my speculation until the end. We are now at the my speculation area of the talk. So proceed with caution. That having been said, my perspective is informed by the realities we've already discussed, and it's been corroborated both by my personal experience and the experiences of my graduate students attempting to fulfill computer science degrees today. The first skill set is investigative skills. We need to be able to scope down the area in which we are facing a problem and learn to ask specific questions about how our assumptions differ from the ground truth. Those of you who've heard from me before know that I find this to be a woefully undertaught and undervalued skill among engineers, precisely because we tend to view debugging or familiarizing ourselves with the system that we're working on not as part of our work, but as a blocking obstacle that distracts us from our actual work of plowing through features and system changes. I think this is a flawed way to view our profession, and one made even less accurate than it already was by the advent of tools that can plow through feature development for us, provided we possess the investigative skill set to identify and understand when and how those solutions make inaccurate assumptions or need to be fixed. Although I have yet to find a book or course that satisfies me on investigative programming skills or debugging, I have more sort of specific thoughts on the matter. So if folks really want to hear about that, I'm happy to talk about that afterward. The second skill set is evaluative skills. We need to be able to select from a range of implementation options based on how those options' benefits and shortcomings fit the bill of our specific situation. I think we often elide this skill set as engineers by deferring to what we've read or heard is a best practice. This works fine much of the time and up to a point. But many of your worst nightmares made manifest in code are the result of engineers applying a practice that, while best in many circumstances, did not suit their circumstances. I think engineers, particularly at more senior levels, need to take stock of why best practices are what they are and determine whether those reasons make sense in each situation where they are being used. More granularly, I think it falls to engineers to learn to specify exactly what their decision criteria are, decide explicitly which of those are optimizing criteria, that is, they need to score as well as possible, and satisficing criteria, meaning that there's a sort of a pass-fail threshold for those criteria. Then we need to be able to document how each of the implementation options stack up against those two types of criteria. A large language model can tell you what most people usually say to do. It cannot necessarily tell you what you should do. But the truth is, neither can most human engineers right now. This skill set would address that. The final skill set is innovation skills. We need to learn to proactively search for the shortcomings of the available options and consider solutions that have not been tried before. These are precisely the solutions that a generative AI product cannot produce by handing us a global average of what the internet has to say about a topic. The task falls to us, I'm afraid, to understand how our status quo falls short and figure out what we could change to improve those shortfalls. We need the ability to proactively identify who our systems do not serve or who our systems serve poorly and why, and how to fix it. I'm confident that these skill sets give us a greater purchase on our roles in a generative AI-enabled world because I see them give us greater purchase on our roles regardless of the availability of generative AI. And I see the reasons for that exacerbated by the use of these tools in development contexts. should we manage to focus on these things, I think we can leverage generative AI in its most consistently successful function as an aid to our process, to aid us in being productive, not in the sense of generating more slop for the web, but instead in pursuit of a more rigorous, more compassionate, a more thoughtful approach to software development. As I mentioned throughout, I'm happy to talk more about any of this after the fact. I'm also happy to take questions. This is my email address if folks also want to email me questions or anything like that. You are more than welcome to do so. It's just my first name at my first name, my last name.com. I try to keep it pretty simple. But if I have time, I'm happy to yield to questions. Cool. Excellent. Thank you. The question was, how would I define competitive programming? Great question. How would I define competitive programming? So in this context, competitive programming refers to the code that people write in service of winning competitions, like the, I forget exactly what it was called, but the Romanian Technical Olympiad and whatnot. We see patterns in that code that look different than the patterns of like code that gets pushed to production. And part of that is the difference in the optimizing metrics between those types of code. Competitive programming, a lot of times the thing that we're competing on is like performance or specifically speed or using relatively little data space or doing something in the fewest number of steps. And that's not generally the optimizing metric when we are working in a team as much as writing code that communicates clearly to our teammates is the optimizing metric. And sometimes that code is like somewhat less performant, but if we're looping over a list of 14 keys, it doesn't tend to matter as much as the clarity of the code does. Does that answer the question? Fantastic. Thank you. Yes. I can, yes. The question was, can I say more about the stochastic parrot paper? I mentioned this earlier in the talk as one of, I guess, what I would call like the foundational papers for understanding sort of the last 6 years of large language model stuff. I would say that off the top of my head, papers that I would include on that list would include the 2017 paper from Google that introduces the idea of the transformer. This is an architectural mechanism that underpins all of the GPT models and most of the large language models that you use today. And another one, I would say probably number 2 on this list would be this paper, the stochastic parrot paper. I believe the official title of the paper is On the Dangers of Stochastic Parrots. And then there's some subtitle that has something to do with the impacts of large language models that might otherwise go overlooked. It was originally written by a team of researchers led by Dr. Tumneet Gabru, who at the time was at Google, and now works for... The acronym is DAIR, and I do not remember what it stands for, but it has something to do with the general sort of global impact of these artificial intelligence tools. And what the stochastic parrot paper does is it points out a number of things about the way that large language models are built and trained that at that time were being overlooked in discussions about their impact on the world more generally. We talked a lot about their economic impact, what jobs they would overtake, whether they would overtake jobs, whether they would affect the bottom lines of companies, how they would do so, et cetera, et cetera. And it points to a number of major ones. Among them, for example, the environmental impacts of training such computationally intensive tools and the environmental impacts of querying tools like this, particularly relative to other technical tools that we had at the time. Another thing that the stochastic parrot paper talks about is the way that it affects, is the way that the use of large language models affects language. They are largely trained on the text of the internet, which isn't representative of the distribution of languages more globally. In fact, what the web does is it tends to center English, and it also tends to center a particular variety of colloquial English that's likely very easy for those of us in this room to speak and understand. And it's not necessarily as easy for folks outside of the demographic that is able to be extremely online to be able to teach and understand. And that has benefits and that has drawbacks. As these tools start to be used to generate language, then we can expect the dominance of these particular linguistic tropes to become more pronounced. Additionally, and this is sort of the counter argument on the mitigative effect of this in the stochastic parrot paper, there's an argument that these sorts of language tropes are already being favored. For example, if recruiting is looking at cover letters for programmers, maybe theoretically how well you can write grammatically perfect English is not an indication of how good of a programmer you are, but it might be an indication of whether a hiring manager is going to accept your cover letter as one that you are going to get an interview for or something like that. Theoretically, the ability to use a large language model to craft a cover letter like that could even the playing field in that way against biases that are already in place. But there are, I think, ultimately 4 different major impacts of large language models that the stochastic parrot paper introduces. And some of them, if you were to read the paper now, some of those will feel like, well, obviously this is a thing that we need to think about. But the reason that that feels obvious is that the stochastic parrot paper initially got people talking about that thing at a time that people were not talking about that thing. We're devoting a lot more attention now in large language model research to the areas that the stochastic parrot paper explicitly called out, which is particularly interesting because the stochastic parrot paper and controversy at Google about whether and how to publish the stochastic parrot paper are a large part of the reason that several of its authors are no longer at the company they were at when they published that paper. Does that help answer the question? Fantastic. Good. Sorry.
I have a question.
Yeah.
I'm over here, right down Broadway.
Hi.
I noticed some tone of skepticism around the 26% productivity number from that paper.
Mm-hmm.
Do you have a closer feeling to what you think, if you could put a percentage on it, or is it, I mean, I understand the point that methodology was pretty flawed and the context you gave was good, but is it maybe underestimating or overestimating in your case? Or do you think that just based on the example you gave where you're in your IDE 1 day a week, that by nature, you're really only going to have a 20% improvement? Or I guess just maybe what's your actual take on the productivity gain?
Got it. Yeah. So the question was that with regard to the 26% paper and given the methodological things about that paper that make that 26% somewhat suspect, what might my estimation be of productivity gain that I have seen with this? It's an excellent question, and I'm not sure I can come up with a number, but I can share some anecdotal evidence based on what I have seen working with colleagues as well as working with generative AI tools myself in attempting to write code. I have rarely sort of built up projects from scratch professionally using these tools, but I've done it on a couple of occasions in the last 6 months. First, in writing a compiler in Rust, which is a language with which I had relatively low familiarity. And the second of them was with building an example repository for teaching basic concepts in productionizing machine learning models. I didn't need something super fancy. I didn't need it to be able to handle terabytes of data. I just needed to demonstrate things like a model orchestration pipeline, an experimentation dashboard, an inference server, which is a fancy word that machine learning engineers use to mean an API that your model sits behind, and the input is data that you want a prediction on, and the output is the model's prediction based on that data. We use the word inference because there's a terminology proliferation problem in machine learning that I'm happy to wax poetic about it another time. But I needed a repository that demonstrated these concepts very simply, and most importantly, ran on as many machines as possible, because the number one issue with doing live interactive code workshops is that half the people in the room can't get the code working on their machine. So I worked with a large language model on this because I was only testing it on this baby right here, which means that there's a lot that I'm not going to figure out about what's going to break on a different machine than this one, right? So my experience with the tools is a little bit braided, I think, into some of the speculation that I put into this talk. But what I have found is that if I already largely understand the functions that I am trying to build, such that if someone else were to build them, I would be well prepared to evaluate them, I find it to be really, really useful. Suppose, for example, I need to generate Docker files, and I know how to read a Docker file, but what I don't feel like doing is writing 8 Docker files. I find that it can be really, really useful for that. Putting together a Docker compose YAML file that composes all of those different services together, it's also really great at that. Writing the beginnings of an API in a widely used web framework with some of the endpoints that I'm going to want, very effective at that sort of thing. And so I found that from getting from 0 to like 70% of the way to where I wanted to go, extremely, extremely helpful, extremely valuable. I found the same thing with the compiler. Getting from nothing to something that sort of approximated what I wanted, very useful, very valuable for that. The last 30%, the fine tuning, understanding what's going wrong in certain circumstances, the difference between what the large language model is saying this code will do and what I'm witnessing it will actually do, that part I have found came from a lot of verification, a lot of testing, a lot of like scenario planning, and a fair amount of debugging as well. And that's not unexpected. I think that what I would say is that the productivity gains that I've experienced in terms of like coding specifically have been chiefly in getting from nothing to getting to a structure that mostly encompasses or at least provides a home for the basic functionality that I need. And I have found that the skill part comes at the end. What I'm going to be curious to learn about in the future is how that breakdown differs for other people who grew up learning with these tools. Because for me, and I'm just one person, so I could be entirely wrong about this, but my perspective is that in order to get that last 30%, I needed to employ skills that I would not be as skilled at today if I had not had the benefit of the last 15 years of practicing them manually in a way that I think folks who are entering the field now do not necessarily have to practice them manually because they can get a head start with these tools. I don't know what the ultimate result is going to be of the difference between the way that I use these tools and the way that programmers who are starting out now use these tools, much in the same way that, for example, when Joel asked the question about who could plan an entire vacation on mobile, I did not raise my hand. I am a millennial. And so that prediction was accurate for me. I suspect that something similar is likely to happen with this, but I have absolutely no idea how it's going to look. Does that answer the question?
Yeah, it does. And I think I have a similar experience where sometimes you mentioned the last 30%, understanding the context and like figuring out the edge cases and stuff. I almost wonder if it would have been better if I had written that part from scratch myself to better know and think of what the edge cases are. By the time it took me to understand, I'm not quite sure how much more productive I've been. And I also think it's interesting of like that blank page problem. And I noticed the same benefit on like when I'm writing English, whether it's like a ticket where it gives me the boilerplate of an email or something and I have to change it to my own tone to match. And like I wouldn't trust it 100% just to represent my own thoughts. And it's the same thing kind of in code.
Sure. Yeah, that makes sense.
Yeah.
Yeah, I figured it out. I think that in the end of your previous answer, you touched a topic how newcomers will upskill themselves in the current time, and it will be probably a little different from what experience we had previously. And right now, and by the way, you work in the at the university, so you probably have this background there. And my question is about, on the one hand, when I think about upskilling current junior developers, sometimes I think that maybe it might be a good practice to make, like, let's say, no AI day once per week, maybe. But on the other hand, I think maybe I'm just way too old and want them to do things in the old way, while maybe in 5 years when they become like middle senior developers, maybe everything will be so different that having this one no AI day will be useless for them. What's your perspective? Like, how do you think does it make sense to force those kind of like manual work so people have this hands-on experience except for AI? Or do you think that maybe it should all go with the flow, and as far as they can deliver what they need to deliver, no matter how they do that?
This is a great question. This is a question that I find myself wrestling with personally on a pretty frequent basis because I am a teacher in a master's program. And so every quarter I get to come up with a course policy about how AI is or is not to be used in my class. For me in particular, it's exacerbated by the fact that I teach remotely. And so I also don't have like in-person pen and paper exam day, which means that I need to think about what it means for me to issue an examination in a classroom where it is not possible for me to regulate the resources that students are accessing while they do that final exam. And I find that right now, my policy changes depending on the class. And I ask students a lot of questions about how they are using these tools when they are trying to complete my assignments. For example, I teach a Python programming class, and I will tell you something about this Python programming class that I want to assure you I told the students first. So I'm not withholding this information from them. I ask students at the end of the quarter when I teach Python programming how they have found generative AI useful or not useful in my class. Students have answered with everything from I did not use it in this class and I did everything manually to I used it frequently on the homework and I think that generative AI could take your class for me. On that latter end, students who said that they thought that large language models could take my class for them, no student who has ever answered that way received higher than a B in my class. And I think that part of that is precisely the attention to detail thing that we've talked about a little bit so far, is that if you want like kind of the gist, then it can be useful for that. If you want to nail down those details, then it starts, its effect as an aid starts to wane. This quarter, my class, I'm teaching topics in software making an impact. This is a class in which students are supposed to build specific skills that I think will keep them competitive in a modern tech workplace for the purpose of using those skills to have through their career the impact that they're hoping to have. And we do a lot of talking about what kind of impact they want to have. How do you evaluate the impact of different technical changes? What are we missing when we evaluate from our perspective off the cuff the impact of different technical changes? And we talk a lot about things like asking good questions, which is important both in a professional setting and also when interacting with a large language model. In this class, I have explicit course policies about AI use that differ from assignment to assignment, and I'm clear with them about what those policies are. The default is that they are welcome to use whatever they would like unless I'm asking them specifically not to use it. And I will explicitly sometimes ask them, for example, if we are going through a debugging strategy, I want them to learn to use that debugging strategy manually. And the reason that I want them to use that debugging strategy manually, I tell them, is because this debugging strategy is useful when you get stuck. What's not useful when you get stuck is all of the other tools that have not helped you so far to get unstuck. So for this type of assignment, I will sometimes ask them, do not use AI, or I will ask them to explain to me how their debugging process manifested itself in each of the steps that I have taught them, which is going to have, I think that if they are willing to undertake the effort to get a large language model to give them the answer in that format, they've probably thought about that question about as much as a student who just did the homework the way I asked them to. Another thing that I will frequently do in classes like this is ask students to explicitly evaluate the results of large language model outputs. I think a thing that sometimes happens is that students who are overwhelmed will try to use large language models to complete their homework and will not necessarily give the review of those results that would be necessary to ensure that they are actually correct. And so what I will do is I will say to the students, I'm giving you a prompt here. I'm giving you some code. I'm asking you to find examples of coupling and cohesion in this code. But before you look for coupling and cohesion examples yourself, I would like you to run this assignment through ChatGPT. And after you have done that, I would like you to look at what ChatGPT has said, and I would like you to tell me whether you agree or disagree with each of the things that it has identified. And I want you to explain to me why. Why do you agree that this would be a good example of something to change, or high coupling or low cohesion? Or why do you disagree? Why do you think this isn't an example of one of those things? Or if you do think it's an example of one of those things, but you don't think we should change it, why in this specific context do you think that we shouldn't change it? What I'm trying to do is give them an opportunity in the homework to develop the skills that I think they're going to need to be able to execute their roles in an environment where they are allowed, expected, encouraged to use these kinds of tools. Because these sorts of verification skills are something that they aren't necessarily using unless I'm explicitly telling them to, precisely because they sort of expect that I'm going to be mad if they use the tool in the first place. And so I have found that, although this might not be a 100% satisfying answer to the question, I have found that the answer, at least for me so far, has been to examine every exercise on a case-by-case basis to understand what learning objectives I have. What is it I want students to know? Because cheating on assignments isn't supposed to be a cheat code. The design of the assignment is the cheat code. I have designed the assignment to make it easy for you to learn, easy for my students to learn the skill. When I give them an assignment, I am making a bet that there is no more straightforward way for them to learn this skill than to do the thing that I'm asking them to do. And if the students that I am training are going to be walking into a career where they are expected to be able to use these tools, then for me to design cheat codes that makes it easy for them to do that requires me to teach them to use it responsibly, which requires me to allow them to use it. So I'm very intentional on an assignment to assignment basis about that. Does that answer the question? Ish. It's a hard one. Thank you.
In terms of the ages of your students, what's the lower quartile, median, and upper quartile?
Yeah, that's an excellent question. So I teach master's students, and this has actually changed from when I started teaching. I started teaching in 2019. When I started teaching in 2019, I think many more of my students were folks who had gotten a bachelor's degree, gone out into the working world, and then came back, and they were trying to change careers. At the time, I was younger than most of my students, which created some interesting dynamics in the classroom. But I would say that particularly with, I'm speculating here, but I think what probably happened was the pandemic hit, the job market kind of crashed there for a while, and undergraduates looked around at the job market and were like, I'm going back to grad school to the extent that I can. And so now I have a lot more students who are coming straight through from undergraduate and do not have like the few years of experience in the working world, which has also been an interesting divide to bridge because it means I need to be much more explicit about what the benefit of learning these skills is going to be, because they haven't already learned the hard way why they need to be in my class. So I have to explain it to them. But I would say my students range from age about 23 or 24 all the way up into, some people are still coming back from having been in a role before. And I would say on the upper end, I have students in their late 30s. So as of this quarter, I have finally reached myself sort of like the upper end. I'm going to be 35 in about 2 weeks. And that will be sort of like, I will now be older than most of my students, which is going to be new for me. Does that answer the question? Wicked.
Thank you. You made a great point at I think the previous question, but the point about teaching your students how to use these tools responsibly. That's something that I've been like really grappling with recently, because I have found myself using these LLMs more and more and more, especially like working in startups, whatever. Like it's much faster pace, and you're producing a lot of code. I was wondering if you had general heuristics for what it means to use these tools responsibly.
That's an excellent question. And one that I will struggle to answer because it's a thing we're still learning a lot about, but I will try. I have found that in attempting to use these tools myself and also attempting to help students use them responsibly, my greatest tool has been asking for feedback from students about what they think worked and then what didn't work. And I have a bit of an accuracy temperature on that because I also grade these students. So I have another person's perspective on what worked and what didn't work for these students, which can be very helpful. And I have found that in using these tools responsibly, the things that have showed up over and over again are making an effort, particularly when we're using it, I'll say specifically for generating code, or I'll also say for asking questions about factual information. I would say, in general, if there is a singular correct answer that is a fact to a question, I generally do not ask ChatGPT for that answer. I go to a normal search bar, because what I'm looking for doesn't require the generation of text, and I want to have a verifiable source. That's important to me for that kind of thing. If what I am doing is trying to generate something, trying to generate code or trying to brainstorm options or those kinds of things, I find it really valuable to keep in mind what sorts of things large language models tend to be strong at and what they tend to be weak at. And I can't go into a ton of detail on what those sorts of things are. Although if you're interested and you have an O'Reilly subscription, which if you work for a tech company, you probably do, I have an on-demand course about that, which you will just have by having O'Reilly access. But in a general sense, it tends to do really well with finding the verifiable sort of like general milquetoast answers to things. It can do a really good job with that kind of stuff. It's also really good at very contextually bound parts of speech. So things like prepositions, if you're trying to write grammatically correct English in particular, tends to be really good at that because the patterns of text on the internet follow very specific sort of like formats that it's really that it's capable of replicating with a lot of accuracy. What it tends to do somewhat worse on is denotationally distinct but contextually interchangeable words, by which I mean words that have different meanings but always appear in the exact same context across text. So great examples of this are proper nouns, people's names. This is a thing that it can sometimes struggle with. And even more than people's names, a lot of times companies' names, libraries' names. So for example, it will like hallucinate library names. It's important to verify those sorts of things. And another thing that it will struggle with a lot of times is numbers, which matters if the numbers matter. So for example, if it's citing like Article 2.5b of case law or something like that, it has seen the exact same text cite a number of different articles like that. And so those article numbers can be interchanged without the text being less plausible, without the text necessarily scoring worse. And so those are the sorts of things that it becomes especially important to double check. So I would say, first, knowing if it's factual, if it's a factual thing, I want a verifiable source using something else. Second of all, I would say knowing the general strengths and weaknesses of the patterns that these things are likely to output. Third, understanding how to gain context on code that I did not write. Because if I'm generating code with this thing, I did not write it. I now need to gather context on it. As you mentioned earlier, I think very astutely, sometimes after I'm done understanding what the thing has written, I'm not clear on whether it would have been slower for me to just write it myself. I find that having a dedicated series of steps for gathering context on code that I didn't write can be really helpful for that. I have a procedure for that. I have a video on it. It's on my Patreon, but I'll also just share the link with folks. If you want to email me, I'll just send you the link to this procedure. I teach it to students. I teach it to junior programmers. So that's the third thing that I would mention. And then the fourth thing I would mention is the verification step, which if we're talking about code is debugging skills or investigation skills, or if we're talking about facts is finding verified sources and making sure that those facts are correct. Does that help answer the question? Wicked. Thank you. Great. Yeah. Is that my time?
Yeah.
Excellent. Thank you.
Thank you so much, Kelsey. All right. I think that's all, folks. Grab more food if there's any more food. Feel free to mingle, but I'm going to call it. That's a wrap. All right.
Thanks for coming, folks.